So you guys had the worksheet yesterday. Do you have any questions off that worksheet? Finding the components from a vector or using the components to find the vector? Any of you actually do the worksheet? So you're saying tomorrow would be a great time to have a quiz on that worksheet? So tomorrow would be a great time to have a quiz on that worksheet. So let's keep going with those vectors. That might be a hint, by the way. Not that you didn't suspect it being Thursday anyway. Kind of figured it was coming. So we've got vectors. We talked about that vector being on a coordinate system, having a magnitude and a direction. So let's say this has a magnitude of 280 pounds, and let's give that direction 65 degrees. We want to talk about some properties of those vectors. One of the things is called an inverse. The inverse of a vector is the opposite of that vector. In other words, an inverse, just like, we know that 7 and -7 are inverses. Why are they inverses? Yeah, 7 plus -7 equals 0. When I add them together, I get 0. I get nothing. So the inverse of a vector, when added to the regular vector, has to end up at 0. In other words, right back where we started. So the inverse of this vector would be that vector. Of course, we need to want to define that vector as starting at the origin. It is going to be 280 pounds. It has to be the same length. What changes is the direction. How do we find the direction? Well, what angle is that going to be there in green? Yeah, 180. Because those going in opposite directions, they form a straight line. So it's 180 degrees difference. So the difference in direction is 180 degrees. So we are going to take the directional angle here, 65, and we're either going to add 180 or subtract 180. In this case, we would add 180. 65 plus 180 is 245 degrees. So that inverse vector is 280 pounds at 245 degrees. Can anybody give me a guess as to why you think we added the 180 here instead of subtracting it? Yeah, because 65 here is smaller than 180. So we're going to add it to get the other direction. What if I had a vector of 719 pounds at 210 degrees? To find its inverse, how many pounds would it be? Still 718 pounds, right? What's its direction going to be? We're going to subtract 180 from it, right? 210 minus 180 would be 30 degrees. This is inverse. That inverse is going to become very important to us later on this hour. So let's take a peek at adding vectors. Vector addition, adding vectors, is just taking the vectors and putting them head to tail, so they can combine to make a longer vector. We actually looked at vectors when we did negative numbers last semester. Remember we said 7 plus a negative 12. We started at 0, we went positive 7, then negative 12 took us back this way, so we ended up at negative 5. Well, those were on a one-dimensional number line, so they either went right or left. Now we're in 2 dimensions, so we can go in several directions. But it's the same thing. The head of this vector went to the tail of the next vector. Let's say I have 400 pounds at 50 degrees, and I want to add to that 200 pounds at 20 degrees. Well, here are my vectors. 400 pounds at 50 degrees. It's going to look something like that. That's this one. 200 pounds at 20 degrees. It's going to look something like that. To add them, I need to put them head to tail. I'm going to take this, and it doesn't matter which one I move. I'm usually taking the second one and put it like that. The head of the first one to the tail of the second one. The resultant vector is the combination of 2 or more vectors, but it is from the tail of the first vector to the head of the last vector. So this is the tail of the first vector, this is the head of the last vector. That is the resultant vector in green. Well, how on earth do we find that amount? Later on in this unit, we'll look at some oblique triangle operations, trigonometry, that'll allow us to actually, we could calculate that length. The direction's a little tougher to do, but we can still find it. For right now, though, we have to look at some other strategies. If I take this original vector, the 400 pounds at 50 degrees, it has components. It has a horizontal component here and a vertical component there, correct? Look familiar? The 200 pounds at 20 degrees has a horizontal component here and a vertical component there. Well, there is nothing saying I can't move those around. I can slide this one out here, so the vertical component's there. Slide this one down here to put my horizontal component right there. What you see is if I call this vector A and vector B, is that this is the x component of vector A, this is the x component of vector B, this is the vertical or y component of vector A, and this is the y component of vector B. I can get to that same resultant by combining the components of those vectors rather than doing the whole vectors themselves. Does that make sense? Any questions? So to combine those vectors, I am first going to find the x component and the y component, the horizontal and vertical component of each of them. Px, how am I going to find it? For the 400 at 50 degrees, well, it's 400 times sine or cosine? Cosine of 50. 257.12 we're going to call it. pounds. P or PY, the vertical component, times sine of 50. Good. 400 pounds times sine of 50. 306.42 pounds. For the 200 pounds at 20 degrees, how do I find the x component? 200 times cosine of 20, right? The x component, the horizontal component is always the cosine of the angle, right? So 200 times the cosine of 20. 187.94 pounds. We got 200 for the vertical component times the vertical is always the sine, yes, of 20 degrees. $68.40 pounds. So then the resultant can be found by simply adding the components. 257.12 plus 187.94 is 445.06 pounds. 306.42 plus 68.40 is 374.82 pounds. And then we have to recombine them to constitute the vector. How do we find the magnitude of the resultant? Pythagorean theorem, the square root of 445.06 squared plus 374.82 squared. $581.87 pounds. Now the angle, I usually draw out the picture. The x component is 445.06. Y component 374.82. This is the angle I'm looking at right here. Now, do I expect that angle to be more or less than 45 degrees? The opposite side is smaller than the adjacent side. I'm expecting it to be smaller than 45. If those two sides were equal, that angle would be 45 degrees. So that angle is the inverse tangent of the vertical, 374.82, over the horizontal, 445.06. So 40.10 degrees. So our resultant vector, 581.87 pounds at 40.10 degrees. What do you think? Good stuff? Let's do an example that might not be quite so bad. We are going to add 500 pounds at 120 degrees to 800 pounds at 210 degrees. So I'm going to write this out. I always make this little table. Just like that. Now I need to find my horizontal component for the first vector. For that first vector, 500 pounds at 120 degrees, the horizontal component is 500 times the cosine of 120, which will give us a negative 250 pounds. Correct? For the vertical components, 500 pounds times the sine of 120 degrees, which is going to give us a positive of 433 pounds. Correct? Any questions so far? So for the 800 pounds at 210 degrees, the horizontal is 800 times the cosine of 210 degrees, which is going to be a negative 692.82. And the vertical will be 800 times the sine of 210 degrees, which ends up being a negative 400 pounds. Now I do have to be careful with my signs here. My resultant here, I have negative 250 and negative 692 is going to be negative 942.82 pounds for the horizontal. I have 433 and negative 400. That's going to be positive 33 pounds for the vertical. So what that means, if this is my origin, I have 942.82 pounds in that direction. The negative just means it went to the left. And 33 pounds in that direction. How do I find my magnitude? Pythagorean theorem, square root of 942.82 squared plus 33 squared. Why did I ignore the negatives? Because I'm going to square them, the negatives don't matter anyway. When you square them, the negatives disappear anyway. 943.40 pounds is my magnitude. Now here, when I'm looking for direction, what I'm really going to be finding is a reference angle here. How do I find that reference angle, theta? Inverse tangent of, vertical over horizontal, good. .33 divided by 940, oops, 2.82. 2 degrees, let's call it. So what's my actual directional angle? Right here. Yeah, it's going to be the supplement. 180 minus that's going to be 178 degrees. So that resultant is 943.40 pounds at 178 degrees. What do you think? Good stuff? Because this was positive, so that means it's above the 180. You're looking at the unit circle. 180 is right here. If it's negative, it would be 182. I'm going to have you guys try something. I'm going to have you add 400 pounds at 135 degrees to 200 pounds at 60 degrees. So px is going to be 400 times the cosine of 135 degrees. What do you get? Negative 282.84 pounds. Good. Py is 400 times the sine of 135 degrees, which is 282.84 positive, right? Px for the second vector is 200 times the cosine of 60 degrees, which is 100 pounds. Py is 200 times the sine of 60 degrees, which is 173.2 pounds, correct? So then we add those. Negative 282 and a positive 100 is negative 182.84. 282.84 plus 173 is 456.04. Positive. So that means we have from 0 negative 182.84 and a positive 456.04. So the resultant magnitude the square root of 182.84 squared plus 456.04 squared, giving us 491.33. And again, we're looking at a reference angle here. It'll be the inverse tangent of vertical 456.04 over horizontal 182.84. .15 degrees. So what's our actual directional angle? Yeah, 180 minus that is 111.85. So our resultant vector is 491.33 at 111.85 degrees. How have you had that? Cool. Not so bad? Oh, you're in radian mode when you did it? Okay. What if we want to subtract? If I want to subtract vectors, if I want to do 500 pounds at 70 degrees minus 200 pounds at 40 degrees. Subtracting involves using the inverse. I have two options. The inverse of this is 200 pounds at 220 degrees. Where did I get the 220? Either add or subtract 180 from the angle. So it was 40, so I added 180. And now it would be adding, just like adding the opposite. Just like when I had, 7 minus 3, I could change it into 7 plus a negative 3. Same thing. I added the inverse of 3 instead of subtracting 3. Well, that's exactly what I'm going to do here. 500 pounds at 70 degrees, 200 pounds at 220 degrees. Px, Py. So Px for 500 is going to be 500 times cosine of 70, which gives us 171.01. Py is 500 times sine of 70 degrees. $469.85 pounds. Any questions so far? You guys need a second to catch up. I feel like I'm flying right now. You guys good? 1 second. Because we're subtracting, so we're changing it to adding the inverse. Yeah. So then the 200 at 220, the x component or horizontal component is 200 times the cosine of 220 degrees. Negative 153.21. And the vertical component is 200 times the sine of 220 degrees. Negative 128.56. So our resultant is found by combining those. So the x component is 17.80. Our y component is 341.29. So what that means is we go over 17.80 and up 341.29. Both are positive, so we're in that first quadrant. So this magnitude here is the square root of 17.80 squared plus 341.29 squared. $341.75. Our angle, is this a reference angle? Yeah. Well, it actually is a reference angle, but it is the angle we're looking for too, right? Yeah. So it's inverse tangent of vertical 341.29 over 17.80. We're expecting this to be really close to 90. Very good. $87.01 degrees. Do we have to subtract from 180? No, that is our angle. So what we get here, 341.29 pounds at 87.01 degrees. Now I want to go up here and I want to do a little experiment. That original vector before we found its inverse was 200 pounds at 40 degrees, right? What would its horizontal component be? 200 times the cosine of 40. You punch that in the calculator, what do you get? 153.21 pounds, right? Its vertical component would be 200 times the sine of 40 degrees. You punch that in, you get 128.56, yes. Notice those numbers are the same except for the sign, the negatives. So the other option, rather than finding the inverse of this with the angle, you could just find the horizontal and vertical components of the original vector and then just invert each component. Does that make sense? So if they're positive, make them negative. If they're negative, make them positive. One application. Phasers. I'm not talking about Star Trek, shooting anybody with a phaser. Phasers have to do with phase angles within a circuit. If you're looking at, we're going to look at voltage here. When you first close a switch on the circuit, again, assuming this is all discharged except for the voltage source. Let's say this is 12 volts. When I first close that switch, how many volts are across the resistor? It's 12 volts, right? The full voltage goes across the resistor because current's just going to flow through that capacitor. But over time, what happens? The capacitor builds to contain the full 12 volts, doesn't it? Once that capacitor contains the full 12 volts, how many volts are across the resistor? 0. Does that make sense? So when we look at a circuit, look at 0 degrees, 90 degrees, 180, 270. This is the voltage across the resistor. The voltage across the capacitor trails by 90 degrees. The capacitor will have lower voltage. The voltage will build. It'll be after. The resistor starts out with the voltage and the voltage goes to the capacitor. So then as the current reverses, the same thing happens. That voltage of the resistor voltage will change first as the capacitor voltage then changes. In an inductor, however, it's not the voltage that builds. In the capacitor, the voltage started out at 0 and built up. In a capacitor, it's not the voltage that builds. What builds in a capacitor? Capacitor resists changes in current, not voltage. So when we first close that switch, how much current is flowing? Next to nothing, because that inductor is resisting the flow of current. So if there's no current flowing, how much voltage is across the resistor? 0, right? All 12 volts is across the capacitor, or the inductor. As the current starts to flow, eventually getting up to the maximum current for this circuit, the voltage ends up, as the current increases, the voltage across the resistor increases. and the voltage across the capacitor decreases. So the voltage on the capacitor leads, I keep saying capacitor. The voltage across the inductor leads the voltage on the resistor. So you get this graph here. Voltage on a resistor, voltage on a capacitor, voltage on an inductor. Now the impedance works very much the same way. The current, the capacitor and the inductor would be switched. The current in the inductor trails and the current in the capacitor leads. So anyway, let's say we have a circuit where we have 12 total volts. Now, of course, this is going to change, but at any given time, let's say the voltage, at a point in time, we measure the voltage across the resistor to be, let's say 9 volts. The voltage across the capacitor to be 4 volts. How do we find the voltage across the inductor? Well, we're adding vectors. In fact, let's do this. Instead of having the total voltage, let's put in a voltage across the inductor. Let's put in a voltage across the inductor of 7 volts. So we're going to add these vectors. We have 9 volts in this direction, 4 volts in this direction, 7 volts in that direction. To add these, we're going to put them together head to tail. So I'm going to move this one over, put the 4 volts just like that, right? Then I'll move this one over. So 7 volts has got to start here going down. So what we're working with is this triangle. We ended up right there. That's where we ended. So to find that amount, we have, what's this horizontal component there? 9. What's this vertical component? -3. So then to find this, that is the square root of 9 squared plus 3 squared. Which is 9.49 volts. And the angle here will be the inverse tangent of 3 over 9, which is 18.04. 18.43 degrees. Now that would technically be, you would say that that's 9.49 volts at a negative 18.43 degrees, or you could say it's 9.49 volts at 341.57 degrees. In electronics, usually it's more appropriate to say a negative 18.43 degrees. What do you guys think? We'll talk more about those phasors as time goes on. For now, I'm going to give you a new packet. In this new packet is page 384 to 385. And Jordan swears he's going to do the homework here now, right? 1 through 33, the odds.